Okay, hello and welcome to this week's Retrieval Market Demo Day. Today's date is Wednesday, the 22nd of June, 2022. On the schedule today, we have Zhenyang, also known as WCG CYX on GitHub, speaking about FCR, Filecoin Retrieval Client and Network. And then we've got William from KenLabs speaking about Filecoin Green integrating with Pando. If you have any questions, please leave it either in this chat or on Slack. Sorry, I've got something in my throat. And yeah, over to you, Zhenyang.
Cool. Thanks, Patrick. I'll share my screen. Yeah. Can you use my screen?
Yes.
Yep, that's great. Cool. Cool. So hi everyone, my name is Zhenyang, the developer of what I'm going to present today, FCR, a Filecoin secondary retrieval client. I am, actually in the middle of recovering from a flu, so my voice might sound funny, and I'll try not to randomly cough or to drink water during the presentation if possible. Before that, let me just quickly do a recap of FCR. So FCR is a Filecoin secondary retrieval client written in Go. It is able to participate in a content network for content delivery and also a payment network for payment delivery. So content network is very similar to ipfs. Routing is currently based on CatDHT with the possibility of supporting indexing service in the future. Should be fairly easy. Provider record is used to indicate an interest of serving a content. To retrieve a content, FCR looks for the provider record and queries for a peace offer. And a peace offer essentially is an offer to retrieve some peace based on a price. That is a price per byte, and currently it is in FIL, the smallest unit of Filecoin. So there are also some other fields contained in a peace offer, which I won't go through in detail today. There is also a payment network. It is based on a custom peer-to-peer protocol. After you create a payment channel with someone else, you can choose to serve the payment channel for others to do proxy payment at a given price. Similar to content network, in order to make a proxy payment, FCR queries for payment offer. And a payment offer essentially is an offer for others to do proxy payment. So user will pay a certain surcharge to do a proxy payment, and it is captured in price per period and a period. So for example, if you wish to charge others 5% for any proxy payment, price per period would be 5, and period is 100. As example, say we have 3 nodes, node 1, node 2, and node 3. Node 1 acts as a user, node 2 acts as a payment broker, and node 3 acts as a provider. So let's say node 1 wishes to retrieve 100 bytes from node 3 with price per byte to be 1. However, node 1 only has a payment channel established with node 2. So node 1 in this case can choose to proxy the payment via node 2 to node 3. And in this case, node 1 pays 105 tokens to node 2. Node 2 keeps 5 tokens as a surcharge and pays 100 tokens to node 3 on behalf of node 1. And the proxy payment is multi-hop. So there could be multiple brokers between the user and the provider. So this is just a very quick recap. So if you are interested in the details of the protocol and wondering how exactly everything works, feel free to check out my last talk. Today, I'll be more focusing on the use case of FCR. So first of all, the first release of FCR is out, currently with the support for Filecoin collaboration network. So this release comes with a number of features. It first of all fixed a bunch of small bugs, small issues of previous POC. I rebuilt the key components of FCR so it is more reliable and robust. One new feature I'd like to spend some time mentioning is that I enhanced the functionality regarding payment providers. Now FCR is capable of managing multiple payment channels to one recipient. And here is one example how that matters so much. Imagine you are running a payment broker. In the previous FCR, you can only create one payment channel to a recipient. In a case that many users wish to do proxy payment through you, for example, in the diagram here, we've got like 10 users wish to pay to the same recipient. What happens is that the one single payment channel needs to process 10 proxy requests, and this causes congestion. What you can do now with FCR is that you can create multiple channels to a popular recipient or popular provider. So the proxy payment requests can be processed in parallel. Another small feature of FCR is that it now supports dedicated payment channel for proxy payment. This is more for people who wish to build a payment network. So FCR has ability to have one or more dedicated payment channels reserved for your own nodes. So the payment traffic between your nodes will not be disrupted. And in other words, FCR can process internal payment requests and external payment requests separately. Okay, what I will do today is to share a simple use case built on top of FCR. It is a video sharing or a video streaming website. Traditionally, it is expensive to host your own video sharing platform because you will need to at least have a large amount of storage to store the videos and a large network bandwidth to serve the videos to the users. However, using FCR, creators can upload videos to retrieval providers or Filecoin storage miner with FCR running in parallel. The website or the video platform will only need to serve the video IDs to the user, who will then be able to stream videos using FCR as a retrieval client. First of all, I'll go through the demo procedures first. So it starts with the user requesting a web page from a web server, and the web server returns a page containing only the content IDs of the videos. What do you see on the right-hand side of the slide is a web page with 3 videos. However, that represents as CIDs, not a typical network address of assets. And when a user clicks one of the videos, the web server sends a request to a browser extension that can further talk to a local FCR node for a request of retrieval. FCR then retrieves the data from the network. The data will be returned to the web page to load. It doesn't necessarily to be videos. It can be image or some text. So the data will be decoded based on the data format and be presented to the user. And this demo specifically involves 5 FCR nodes. One FCR node of the user, which will be us. 2 FCR nodes acting as a payment brokers, which we have already established the payment channel with. And 2 FCR nodes acting as a retrieval providers who are actually hosting the content. Also, because I have to say that I am a terrible front-end developer, so it is a little bit hard for me to develop an extension that can talk directly to the FCR node. So in this demo, I will also be running a small proxy server that proxies the request from the extension to FCR. Please note the proxy server isn't necessary and can be completely avoided. And the demo. Okay, so as you can see, I've already got the web page loaded in the other tab. So we've got like 5 videos here, and 2 of them I actually downloaded from KenLabs YouTube channel earlier today. So we have also got the extension where you can see some basic information of FCR and do some basic actions on FCR. Let me just do this so you can clearly see what is happening behind the thing. So on the left-hand side, you can see like 6 terminals. We have got the small proxy server I mentioned earlier at the bottom. One FCR node that belongs to the user, that is us. 2 FCR nodes acting as a payment brokers in the middle, and on the top, we've got 2 retrieval providers. And now let's load one of the videos. And it fails to load. That is because I have turned off the permission to retrieval in the extension. If I enable the permission and do a refresh of the web page, you can immediately see that the video is playing as FCR retrieves the video from the retrieval provider. Oh, and also if the video appears laggy from your end, it's probably because Zoom has compressed it. The actual video is not laggy at all from my end. Let me pause it for now and do some explanations. So you can see that we have got a lot of retrieval requests from the web page to FCR through the proxy server. That is because the video is split into split into multiple segments of data. It also appears that the retrieval process is paused. Now, that is because Chrome only cached the first part of the video. It will continue to cache more if I press play. And as we approach the end of this part, every retrieval is done via the brokers with a proxy payment. And because the 2 retrieval providers are running on my local machine, so what you can see is that the requests get split randomly between these 2 nodes. In real-world application, assume one retrieval provider is sitting just next to your door, be your neighbor, while the other one is sitting, say, 100 miles away. Then FCR basically will prefer to retrieve from your neighbor because they will be the first to respond to your request. And what I'll do now is I will resume the video and I will randomly shut down or restart one of the providers or the brokers while FCR is retrieving, and let's see what happens.
So much about them. And unfortunately, we built it on a very fragile infrastructure.
See that if FCR fails to retrieve a content, it automatically switches to the other provider. And the same works for the broker as well. If I shut down one of the brokers, the retrieval still works and the video is still like playing. So the user won't notice any difference. Okay, so what happens is that FCR, in the case of failing to retrieve a content from a certain provider, it will automatically choose to retrieve from the other provider. That is because content is, well, addressed by its content ID. So it doesn't really matter where the content is coming from. The same works for the payment network. If one broker isn't working, FCR will use the other available broker. It doesn't matter which broker it uses. As long as the payment is delivered to the final recipient, everything is good. And also, as mentioned somewhere in this video, in such systems, there won't be a single point of failure. And of course, you can like jump between the videos. It just work like normal. Excuse me. And and because how the video is encoded into segments, it is dynamically loaded. So you don't need to pay for the entire video. You just need to pay for the part you watched, or maybe actually the part Chrome cached. Maybe that's a more precise way of saying it. So let's go back to the slide. Okay, so that's a short but hopefully interesting demo. The demo has been released, by the way, so feel free to run it yourself. Okay, right now I would like to share a few thoughts. It is just my own opinion, so feel free to disagree. I believe there are several roles in an FCR network. There are content providers, payment providers, content consumers, content platforms, and content creators. So a content provider is a person who wishes to serve content for payment It could be a Filecoin storage miner who also runs an FCR in parallel, or it could just be a retrieval provider. And in order to maximize reward, it will prefer to cache, to store, and to serve content listed by popular content platforms. And the payment provider is a person who delivers payment to content providers. It can host a number of nodes to form a payment network. Similarly, in order to maximize reward, you can imagine that it will aim to build a network with high coverage of content providers or content in general. For example, a user is likely to choose to establish a payment channel with a broker that has 95% coverage of popular content providers over another broker, let's say, has only 50% of coverage. And a content consumer generally is a person who is willing to pay for content. As mentioned earlier, it will prefer to establish a payment channel with a payment network with high content coverage. So to minimize cost while maintaining high retrieval success rate. What's more is that you could imagine a consumer can negotiate a deal with payment brokers to have itself be a payment destination to receive payment, so that it will be able to serve any content that has been cached locally. For example, if I was a user, say I watched a lot of videos from YouTube, I can send a payment broker with some money to ask it to establish a payment channel with me. So I can also become a small content provider to serve my video cache. Then maybe my neighbor will choose to retrieve from me, since I'm just sitting next to the door, so it will be extremely low latency. And I guess the most important piece is a content platform and content creators. As demonstrated earlier, that a content platform will just need to list and maybe filter content IDs created by the creators. First of all, it does not need to handle storage of content or serving of content. The cost of operating will be much lower. And I would say that even small studios will be able to start their own video sharing platforms. And remember that at the start of COVID, even the giant YouTube starts to lower the video quality because there's just too much demand on the bandwidth. However, if YouTube videos are stored in a peer-to-peer way, you don't need to stream all data from YouTube directly. Part of it can come from the retrieval providers in your local city, or maybe even your neighbors just next to the door. And to extend that a little bit, we now have the possibility of serving content that is not possible as of today. Well, at least not economically feasible. Think about a platform that supports like streaming 8K videos, or maybe, I don't know, 32K videos if there is a thing to a large amount of users simultaneously, or high definition VR content. If it is to be provided by YouTube, well, I don't know, I guess you will need to watch at least 5 minutes of non-skippable ads so they can cover the cost of storage and bandwidth. Cool. So yeah, so that wraps up my talk today. Again, first FCR is out. The first release is out together with a demo I did earlier. List of boot nodes for Filecoin calibration network has been deployed. Feel free to check it out. Issues are more than welcome, and more documentations are work in progress. So thanks.
Wow, thanks, Zhenyang. That was great. Just one clarification to add is that the term content providers we've been using to refer to people who actually provide their content to a retrieval network. So there was just people might have heard slightly different definitions of that term across different talks or different bits of documentation. Okay. So just to clarify for everyone, I've got one question, which is in the browser extension, did you actually have a Filecoin wallet set up there, which was paying for it from the browser, or was it proxying to a FCR node locally, which was managing the payment side of things?
Yeah, everything is proxy to the FCR. So
okay.
Yep.
Cool. Yeah. Anyone else got some questions? We went through so much there. It covered all parts of retrieval networks. Awesome. Thanks, Zhenyang. Right. Well, next is William from KenLabs to speak about Filecoin Green and Pando.
Hey, Patrick, thanks. So I'm going to share my screen. Okay. Can you see my screen?
Yes.
Okay, so this is what I'm going to introduce today. Actually, I have talked about Pando and a bit of the Filecoin Green in previous demo. So today I'm going to show you what exactly KenLabs have been doing and what's the future plan in the Filecoin Green. First of all, so what is Filecoin Green? Let me give a quick introduction. This is an initiative or program that aims to measure the environment impact of Filecoin and verifiably drive them below zero. So it's to make transparent and substantive environmental claims. So this is Filecoin Green. And what is Pando? So Pando is a Web3 database that ensures access to notarized data. So in Pando, IPLD is a first-class citizen. It will keep data storage consistently available with lightweight, unbiased data access. It also discourages historical revisionism. So this is Pando. So the original idea of Pando is just to serve as a sidechain service. In the graph here, you can see as a key component of a reputation system. So Pando will receive the metrics from the Filecoin miner, and the client can then fetch the data from Pando or the reputation system. So this is the workflow of the initial idea of Pando. And then now we are integrating more and more clients, providers, or consumers with Pando. As you can see here, we are talking about Filecoin Green. And this is the future state of Pando. We will name as JWTDB. It will be immutable, verifiable, and the DID enabled. So in JWTDB, you will also see IPLD data can be processed and computed, which is processing and computation enabled. This is how we are going to serve the Web3. So today, what we are going to focus on is the facts of the Filecoin Green and how Pando can cooperate with this project and serve their workflow. So currently in Filecoin Green, the idea is great, and the data storage and the system are very centralized, and the crucial Filecoin Green data require authenticity. The last thing is the Filecoin Green, the business logic. It requires a ledger feature to manage the data change records. So I will show you why we are talking about it here. This is currently what Pando has supported Filecoin Green. So there are 4 components here in the graph, in the diagram. So first of all, it's a location API, which was set up by the Filecoin Green team. This is a Web2 hosted resource. It's a JSON API hosted somewhere. Now I think it's one of the endpoint is on AWS. So JSON API. In order to ingest the data to our Pando system, we were not going to change too much in the existing Filecoin Green workflow. So we developed a standalone service called GreenSync. This service will periodically fetch data from the location API. So it's a JSON data, a piece of JSON data, get it inject to Pando using the IPID data. So this is the specification of data model Pando is using. So primarily GreenSync, the two things, fetch the data periodically and transform into IPID data model, published to Pando. On top of the Pando storage, it also supports the GraphQL interface so that from the dashboard or the client, the data can be queried over GraphQL. So the location API, now what we are talking about, it's the miner's location. So this information, as they are stored in Pando, so we can also build a dashboard. Now Pando also enables the querying location by miner ID. This is the API we can use to query the very specific miner and see its information. So we also developed a simple dashboard to visualize the miner location on the map. So this is what Pando has already supported. I have already covered this point, so let's move on. So this is the future plan. This will also be the next step. So firstly, in the Filecoin network, for storage provider, their metrics need to be reported and get audited. So the reports, so the storage provider, they reported crucial metrics to Pando. And the auditors will access and verify the metrics from Pando, which means firstly, they need to fetch the metrics from Pando and verify. And at last, it will also need to write the data back to Pando. In this scenario, authorization must be enabled in the metrics data access. So with this verified metrics, what Filecoin Green can achieve. So this should be able to showcase the outputs or improvements of storage provider via Pando. So by how? By comparing that to the estimate based on Filecoin Green methodology, which is already shown on the Filecoin.energy dashboard. So there's an estimate. So according to the metrics, the verified metrics compare with the estimation, so we can see how the specific storage provider is improved its energy efficiency. So this is also part of the aim of the Filecoin Green. We hope to see the improvement from the storage providers. So all these three use cases or the features are what Pando is going to support in the second half of this year. Okay, we hope Pando can make Filecoin Green reporting more transparent and verifiable. Now I can show you a small dashboard. So this is a dashboard we created for the demo purpose. Filecoin Green has a similar dashboard. So we need to see how much and if this part of the feature can be consolidated or how we can merge them together in the future. So now this is just for demonstration purpose. So you can see from the map, these are all the miner locations from the original location API. The data is fetched from the Pando GraphQL interface. So if we go here, actually, so these are the locations. So if we try to click some location, actually before this call, I have checked some of the miner location. Some has valid transaction data. So for example, this location, this miner, it's in Denmark. So these information are the transactions or the energy they purchased in the past. So primarily in 2020 and 2021, so multiple transactions, it shows us how much energy they have purchased and who is a buyer and who is a seller. There's a lot much more information in the transaction API response. I just listed 5 key fields here. So if needed, we can also show more. And some of the miner has no transaction reported. So this is also a part of the work that need to be done in Filecoin Green, or not. It's not. I'm not sure if it's their responsibility, but at least if we want to see the best outcome from the initiative, we should find a way to get all the transaction data from these miners. So if you see here, the fact is that there are very few transactions data available from the miners. And if we move to Asia, to be more specific, in China, I also see a couple of miners, they have available data, transaction data. Yeah, you can see. So this is basically the showcase of what we can see from the map, and what transactions we can, kind of transaction data we can fetch from the miners. Okay, so this is a simple example demo of the front end, the dashboard. Behind the scene, the data is periodically, so every 15 minutes, fetch from the location API, get synchronized to Pando. Okay, I think that's it for today, and this is what Pando can support Filecoin Green. Hopefully, once we have more features or more use case supported by Pando for Filecoin Green, so we can come back to demo more to folks here. Okay, thanks.
Awesome, thanks, William. I've got a couple questions. One is about GreenSync, so the sort of translation layer for the ingress of Pando. Is that generalizable to other clients who want to store data in Pando? Could we take GreenSync and turn it into just sort of I guess just like an ingress module for Pando? And then the second question is, you're using GraphQL to fetch data back out of Pando. Are there other options there as well, or what sort of translation do you have to do between the GraphQL query and then fetching from the an IPLD data store?
Okay, thanks for the questions. So firstly, for the GraphQL, natively Pando supports GraphSync. So the reason for GraphQL is simply because the existing dashboard, so Filecoin Green, they provide, they can use GraphQL interface. So that's part of the work we have done in past couple of weeks. So to support the GraphQL interface so that it can be easily integrated with their dashboard. So if you prefer GraphSync, you can also use it for sure. There's no problem. And the other thing is the GreenSync. Yes, so it can be reused. It kind of it's a very generic module. So the primary transformation done by the module is from the JSON to IPLD. So if you have any JSON API or JSON data resource on the network, you can surely use it to do the similar work. What you need to do is just to define the schema, the IPLD data schema you would like to publish, so that it can be connected with Pando, getting integrated. We can think this is a good idea. So we can think of the solution. So we make it more generic and see if we can publish as a module, so that share with the community. If anybody has any interest, so feel free to use.
Cool, thanks. Yes, I think that'd be interesting to see if we could generalize it just in terms of, I suppose, what data is coming into it. And in that case, it's JSON, and then translating it into IPLD. Yeah. Cool. Any
This is
other
also
questions?
one thing.
Oh, sorry.
So this is also one thing I realized. So in the society or the community, I see some requirements, some interest transforming from the traditional Web2 data format or model like JSON to IPLD. So once we see more and more interest or requirements, so we can focus more on this part of the work to bring the Web2 data into Web3. Sorry, Patrick, go ahead.
No, sounds great. I was just going to say, any other questions from anyone? Cool. Well, yeah, two amazing presentations. I'll wrap up the recording.